Hi guys, welcome back to my channel, and today I'm going to be talking about Kruskal's minimum spanning tree algorithm. Okay, here's a graph I drew up earlier. Alright, so what's a spanning tree? A spanning tree is just a tree of a tree made from a graph that has all of the nodes of that graph, but only has enough edges so that there's a path between any two edges in this graph. So for example, if you have if you have this graph, you can make one spanning tree that's just this, and this. And as you can see, we're missing a couple edges, but this is still a tree, and it makes sure that between any two nodes in this graph, there's still a path between them. Now, the main problem is when you're trying to find a minimum spanning tree. A minimum spanning tree is just a spanning tree, except you want to minimize all of the weights in that tree. And Kruskal is a classical algorithm that helps you figure that out. So, if we look at this graph, what would come to mind first when trying to figure out a minimum spanning tree? Well, to make a spanning tree, without worrying about whether it's minimum, all you'd have to do is start from any node in the graph and keep on adding edges to reach all the nodes. Now, the problem arises when for example, you try to add 4 to 3. This results in a cycle, and as we know, trees has to be acyclic. So here we're still missing one node, so then we can just connect to 5 from this different way. Now, this is how you find a spanning tree, but how would you find a minimum spanning tree? One obvious way to try is just to keep on connecting the edges with the least weight. So in this case, first you connect these two, then you connect this, then 3 to 6, and now you'd go to 1 to 5, 2 to 3, and then the next one is 2 to 5. Well, in this case, it's creating a cycle, and it's not actually contributing to the spanning tree at all because 2 and 5 are already in the tree, which is why it's making a cycle. So in this case, we'll just skip over that edge since it's not adding any new nodes. And then after that, the next edge is 7, so I'll add that in because 4 is not in the spanning tree already. And after 7, we come to our final node 9, but as you can see, this would just cause another cycle because both of these are already in the MST. And with this simple algorithm, we have found the minimum spanning tree of this graph. And this is exactly what Kruskal is. All you do is sort the edges by the weights and continuously add the edges until you find an edge that creates a cycle. Now, if an edge creates a cycle like 6, you simply skip it and move on to the next edge. So, how would we figure out if two nodes are of are making a cycle? Because if we can do this efficiently, this algorithm will come very fast. And we have a perfect data structure for that called the DSU. As you're going along, you unite these nodes that are being connected to the MST, and if you find two nodes that are already in the same set, then you know that they have that edge will not be used in the minimum spanning tree. If you don't know how a DSU works, I'll link a video in the description where you can learn how it works and how to implement it for yourself. So now let's look at the code. At the top here, there's just a DSU, which I won't be discussing today. And this is just code to input a graph. All this is doing is storing the edges, and it's putting the weight first because, as I was talking about earlier, you have to sort them. by increasing of their weights. Now, if they're in the same set, just skip over them, but otherwise you make sure to unite it because you have to mark that these two are part of the same set to eliminate um, the case where you add a node that causes a cycle, and then you simply push to the MST. And that's all Kruskals is. It's very simple, but it comes in handy in a lot of problems because if you can twist a problem to create a minimum spanning tree, you can solve it very quickly, which provides a lot of utility. Okay, I hope you liked this video. Thank you for watching. I'll link some practice problems in the description. This is mostly a USCO Gold and Platinum level topic. If you liked the video, please like, share, and subscribe, and I'll see you next time. Bye.